Hey guys, welcome back to part 2 of our video series Patterns in Nature. In today's video we'll be going over through branching pattern in nature, which is quite admittedly one of my favorites out of the 4. The reason being it has quite the amount of detail and texture given it is coming from a programmatic perspective. I have edited the previous video and I have not uploaded it yet. I'm thinking I should upload it after I've completed the series so you guys have something to watch in the meantime from the new channel, right? And from the previous video I have come to the conclusion. From the previous video I have come to the conclusion that my explanations are quite not digestible. It is quite complicated to understand what's going on and stuff like that. So in today's video I'll be taking a different approach to explaining the concepts, and that will be first taking you through paint and detailed explanation of how the pattern works. Detailed explanation of how the pattern works and how to create the pattern in programming and stuff like that, and then showing you my code that I've already written down in P5.js. Honestly, I don't think anybody's gonna sit down to see me type all the code down. All you guys want to see is the code and the explanation of how the code works. So I think we'll go with that route. So let's start with what is a branching pattern. So I'm going to pull up an image and I think that will summarize branching pattern. So this is our branching pattern, and this is going to be the one we'll be creating today, in the sense we'll be branching from a central point which is going to be a center. And when I mean central point, I don't necessarily mean always the center. A central point could be here or here or here or anywhere in a given point space or a point cloud. You just have to define the central point before you are branching out. And applications of branching pattern or where it is found in nature is quite easy to find. We have leaves, we have trees, we have even the lungs, the bronchi cells and stuff like that, even mountains. We all have this branching pattern, I think quite beautifully laid out in nature, and it is one of the easiest patterns to find. So with that being said, let's jump into paint, and I'm gonna walk you through this process and how we're gonna deal with it or what we are expecting to create. So first let's draw ourselves a point cloud. And within the point cloud we're gonna have a couple of points. So now if you haven't watched the previous video and do not know what a point cloud is, to summarize it in basic terms, it basically means a given number of random points in any given shape, right? So for our shape we have a circle. It could be any shape really, a star, a triangle, a diamond, a square, a different polygon and stuff like that. Even it could be a chat bubble, who knows. You could put points inside this chat bubble and call it a point cloud. And we'll have n number of points inside this point cloud, randomly distributed. I think that is going to be the key takeaway here. That is, the points inside the point cloud are randomly distributed. And the way we're going to do that, obviously computer can't randomly generate things quite randomly, because computer needs some input to generate a series of numbers, right? But the more random our point cloud is, the better for us, which I'll explain how to create once again. And also it is have to have a uniform distribution, uniform probability distribution, which means if I take this circle here and this given area and I move it anywhere around the circle, inside the circle, it should always have 2 points in it, right? The distribution should be equal. So if I say near the center, if it has 1 point, and if I move it towards the outside, it should always have 1 point inside the same given area. So that is going to be a point cloud. the second step, what we're going to do is find a point closest to the center, because our central point is going to be the closest to the center, our defined point. You can have it the farthest from the center, it'll be fine. For example, you can take this point and connect it here, 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 so on. And now you can see there's a branching pattern appearing on the screen. So that's what we're gonna do, but with the centermost point as our first point, our parent point, right? So our closest point is going to be this guy, for example. So we're gonna connect him to here, connect this point 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 to here. So now you can actually see there's a pattern appearing, branching pattern appearing, and I think through the process I've drawn this, you could infer a solution, and that is we'll be using what is called a node network, and we'll be connecting the points to in the network. So what I'm saying is, first we're going to define a point, and let me bring up the brush real quick. Black, right? So points is going to be an array of points in the point cloud. So this array is going to hold all the points in the point cloud. So it could be x, 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 and the way we're going to do this is can differ from person to person. I could either use the x and y coordinates, or I can use the index of the x and y coordinates, which is going to be easier because now we have only one value to worry about, and we can get both the x and y coordinates, which we'll get through when I'm showing you the code. So we have the points array, and we'll also have a network array, which is also an array. So for the sake of this video, I'm just going to make some things clearer. First point, second point, third point. So the way we're going to do this is, so the first point is going to be our closest point to the center, right? And the second point is going to be the closest point to the centermost point. So from here, this is going to be our closest to the center point, and the second point is going to be the closest point to the closest point to the center, which is this point. So now we're going to draw a line from the centermost point to the point that is most closest to the centermost point. Like that, we'll draw an array, a line, and we'll take these 2 points that are in the points that we have connected, which is 1 and 2 right here. I'm gonna draw it out for you guys so you can see. So we have 1 and 2 points from the point array. After we connect the line, we're gonna push that points, or we're gonna shift them, right, into our network. So 1 and 2. Now within the network we have 2 points, right? Then we're going to take the third point. Our third point is going to be the third closest point to the centermost point, so which is going to be this point, and we're going to ask, so which point in the point cloud am I closest to? In the network I'm closest to. So in the network we have 2 points already written down for us. We have added them because we have already connected them from the point cloud itself. So this is going to be a point cloud, this is going to be a network. Within the network we have already 2 points. So the third point, I'm going to cut this out, so because we have shifted this, right? So third point is going to be, okay, so I'm going to explain why we have the third point as the third closest point to the center, because we have taken the distances from the centermost point and we have sorted them in a way that it goes from ascending order, smallest to biggest, in respective to the centermost point. So number 2 has the least distance compared to any other point in the point cloud to the center, and number 3 has the second least distance from any other point in the point cloud to our centermost point. So in that manner, if we ask, okay, now we have the third point is closer to which point in the network, right? And we're going to ask, okay, the third point is closest to which point within the array, within the network array. Within the network array we have 1 and 2, so you can see which is closest. We have this or this. So obviously 1 is the closest to 3, so we'll connect a line, and 3 is gone down, is going to come here, and 3 is joined into the network and is removed from the point cloud. So the next is going to be the third closest point to the centermost point, which is going to be 4. Just forget this one. So which is 4 here? For example, let this be 4, yeah, this point. So we're gonna ask 4 is closest to which point in the network. So it's obviously closest to 3. So we'll make a line in 3, push it to 4, to the network. And next point is 5. So I'm gonna mark 5 as this man. This arbitrary, I'm obviously taking it in terms of my visual senses. It's not accurate at all. So the 5th is the 4th closest point to the center. So we're gonna say, well, the 5th point is closest to which point in the network? It's obviously closest to 4, or in this time, okay, it's closest to the center itself. So connect it, push it into the network, and remove it from the cloud. So in that way we're gonna connect every point in the point cloud, iterate through every point. So you can see the branching pattern appear one by one. I hope you guys understand till here. If you guys did, it's going to be easier from here on out. If you guys didn't understand, please rewind and try to understand it a bit more. So with that explanation out of the way, let's get into the code and see how the code works. So I'm going to open a browser. So as I mentioned earlier, I have already written down the code and I'm going to explain it bit by bit so you guys have a better understanding. Instead of me typing away a section of the code, I'm going to do a little bit of coding train style. Okay, so we have the pattern appearing, as you guys can see. So I'm gonna take you through this. I'm gonna out of mind, out of sight first. So the first thing we're doing in function setup basically means run once before when you play the play button, right? So when you play the play button, the setup function is going to run once and never again. We're gonna use the function setup throughout the series because we're not drawing anything. It doesn't need to be like a animation. We are doing a static image from the get-go, so we'll also always be using function setup. So the first thing we're defining is canvas. We don't have to do a variable to hold the canvas. I'm doing it here because I'm saving the image later on, which needs the canvas variable. Other than that, you don't have to do it. Canvas is 500 by 500, which means the height and width, and the background is set to 0. Next, we are initializing the variables, which is called, we have radius, which is the radius of the point cloud, which means the shape of the circle which holds the points inside. So the circle's radius is going to be 200, and when I mean 200, I have already in the previous video I have mentioned a quirk of P5JS or something with the programming logic. I do not know what I'm doing wrong here. Basically, if you want the radius of the circle of the point cloud to be 400, you have always to divide it by half amount, so you have to divide it by 2. So in this case I want it to be 400, so I'm writing it down as 200. Next we have the number, which means the number of points in the point cloud. I'm going to reduce this down to 30 so you guys can see what's going on better. Next we are defining theta and length, x code and y code. This I'll explain it later on why we're defining all these variables, but for now just focus on these four. Theta means obviously the angle, length is length, x code and y code is the x and y coordinate that we're going to push into these two arrays. So this separate definition or initialization is specially for arrays. So the way you can do that multiple arrays at the same time is put all the stuff variables into an array and define them separate arrays in an array. So again, the things you have to focus on in the first part of the video, or the primary steps, is theta, length, x and y coordinate, and x and y array that are going to hold the x and y coordinate. So coming down we have translation width by height, which basically means primarily when we start, our x and y coordinates is going to be here. So when for example I'm going to draw, you can see the circle is starting from the very corner. It's not starting from the center, is it right? So this point is going to be a starting point. It's going to be 0 and 0. But we do not want that, right? If we want to draw a radius with radius 4 and with a center of 0 0, the point cloud is going to draw from here. The point cloud is going to be like this, which we don't want, right? So the best way to do that is we have a canvas and we're going to ask the center point in the canvas, which is going to be height by 2, width by 2. Now we're going to translate that point, which is going to be x and y, into our new 0 0 coordinate. So this time when we draw a point cloud, the center is this x and y coordinate that is transformed into 0 0. So now we have a proper point cloud, and that's why we are translating values before we do anything. So the next important step in the programming process is obviously generating the point cloud. So I have mentioned in the previous video explosion, but I wasn't as clear as I wanted it to be, so I'm going to try to explain it more clearer in this video. So for let, we are going through a for loop which can initialize from I as 0 and it can run through the less than number, which is going to be which is basically going to be the number of times we have defined in the number variable. So it's going to run 30 times, and each time it iterates through the loop, the variables defined are going to be redefined. Basically for every loop there's going to be a new value in theta, length, x code, y code, and the amount it pushes into the x and y array. So let's see what we are doing with the defined variables. So the first variable is theta, and we're going to call it as random 0 to pi, which basically means we're going to take a random value between 0 and 2 pi. 2 pi basically means the whole entire circle. So for the first iteration, you can see random value is going to be a different value compared to the second iteration. And the length variable, what we're doing is math.square root random radius into radius. And the reason why we're doing this, I'm going to quickly show you why. I'm going to remove this math.square root here. So you can see one big problem when we don't take the math.square root, when we don't take the square root and multiply it by the radius itself, is the density, as I mentioned earlier. When we have to take a shape, a given area, and we compare to the areas of anywhere else in the shape or the circle for this particular program, the density always stays the same. So if we take for the centermost circle, I mean centermost circumference or area at the center, we have 1, 2, 3, 4. But when we take it outside, we have 1, 2, 3, 4, 5, in this circumference it's farther away, farther away, farther away. I'm going to explain to avoid the confusion. So this is one of those concepts I haven't explained it properly in the previous video, which I'll try my best to explain it properly in this video. So what I'm talking about is when you don't take the square root, you have something like this, you end up something like this. So what this basically means is the concentration of points at the center is greater than the concentration of points at the near the circumference, as you can see clearly. So this obviously is going to be a problematic interference with our pattern that we are going to create. So the obvious solution to that is, I've already shown you here, is taking the mat dot square root, which is going to instantly distribute it properly. So now we have two, it feels more equally distributed, right? So again, length is also going to be a unique value each turn of the iteration. For each loop is going to be a different value. So we have x coordinate and the y coordinate. So x and y coordinate are going to be the points you can see here, the circles, white circles. So we have to define where these points are going to be in a canvas. So I and you know we can draw random points with a pen on a paper, but the computer needs an x and y coordinate to be like, where can I put the point, right? A definition. So we're going to define x coordinate as the length into cos theta, which means length, which is the mat or square root we discussed now, and any random point within the 2 pi. That's going to be a theta. And the y coordinate is the same, but instead of cos we're using sin theta for differentiation. And next we're going to push the x and y coordinates into our x and y array. Why we are pushing? Because each iteration we are inserting a value into the array, right? So at the end of the loop, the length of the array is going to be equal to the number we have defined earlier, which is going to be 30. Next is an outside function. So you guys can clearly see we have a distance function written here. So what is going on here is, let's come up. So we have something called a distance array, which we have defined in the array initialization. We have x array, y array, and then we have a distance array. So to simplify, what this distance array does is take the distance between x and y from the center and push it into the distance array. So here I have given radius, which is wrong. I should give the x and y coordinate of the center, but for here it's a center, so we can just put 0, and I've already defined it in the function below, our distance function here, which returns a mat dot square root. I'm going to explain it to you guys right now, so I don't confuse anybody or scare anybody away. We have like too many lines of code and oh my god. So what we're doing is we have a distance array, right? Is going to be an array. So since at each initialization of the loop the x and y coordinates become unique, right? So that means for the first iteration y value is going to be different, from the second iteration y value is going to be different. So what we're going to do is, for each iteration we're going to take the x and y value and take the distance of those x and y value from the center. So this is an example. We have the first, for example, this is going to be our first iteration. We have an x and y value, right? We have defined x and y coordinate as length into cos theta or sin theta, and then we're going to take the distance using a distance function. So d equals so this is going to be our distance function, which is going to take the x and y coordinates, which is going to be x2 and y2. Why x2 and y2? Because x1 and y1 is always 0 because we are taking it from the center. Remember I said we want to take it from the center. Since we have translated the center value, it's always going to be 0. So basically what we are doing is taking the distance of every point we are generating, the 30 points we are generating, and taking their distance respective to the center, and we are pushing those distances into a distance array. So it's going to be 30, 20, blah blah blah, whatever, right? And one thing to note here is, if you want to take a different point, a central point, if you want to vary it from, let's say you don't want it to be the center, you want the point to be the farthest point from the circle. So what you have to do is define that point earlier on as the variable as x1 and y1, and then put them here instead of x1, y1, right? So now let's take a look at the distance function we have defined, so which I have written it earlier on, which is taking the math square root of math power. Basically means taking the power, right? 2 means square, 3 means raised to 3, and 4 means raised to 4, stuff like that. So we're taking the math power of x minus 0. So basically what this means is x2 minus x1. x2 is x, which is taking the, okay, I forgot to talk about the arguments we are taking in the distance function, which is x1, x2, x1, y1, and a radius. It's my mistake, this shouldn't be a radius, it should be x2 and y2, but I have already done it, so I'm gonna fix it for you guys quickly. x2 and y2, just for a showcase. So the distance function should actually look like this, like the distance line function below. It should take an x1, y1, x2 and y2. x1 is always going to be 0, x2 is y1 is also going to be always 0 in our case, because we are taking the centermost value. x2 is going to be the value you're iterating through, which means the length we are defining as x and y coordinates is going to be x and y. That pretty much is it. And so we're going to call the distance function when we are going to push the values inside a distance array, which we have done here. So we are like distance array dot push the distance value of x and y coordinates respective to the center. So then I have visualized the points here as white circles, as I mentioned earlier. I'm going to reduce the size here to 7, so it's quite easy to see. So let's move on to the next step, which is sorting the distance array. So as of now, what it stands is that we have a distance array, we have defined a distance array, but the distance array is kind of in a random state. It's kind of shuffled, the distances are shuffled, but we want to take the smallest distance first. The distances are going to be very shuffled, so it's going to be 50, 10, 20, 11, etc. So what a sorted distance array is going to do is exactly what it says. It's going to sort it in terms of smallest to biggest. So it's going to be 11, 20, 50. So that's what we are doing here. We are like sorted distance array or sort distance, which I have defined it again somewhere here. Let theta is equal to, so here in the first variable initialization, after x and y coordinate, I have initialized a variable called sort distance. I'm gonna say copy the array first, right? 3 dots and distance array dot sort, then in the sorted, I mean the copied array, sort the copied array from smallest to biggest, which means a, b and a minus b. So once that's done, we have to get the indexes of the distance in the distance array using the sorted array values. So what does that mean? That simply means we're going to take the, I'm going to quickly go back to Paint, because this is one of the concepts I haven't explained clearly in the previous video. and I'm going to try my best to explain it in this video. I'm going to take a pen because black. Okay, so first we had x and y arrays, right? X, and the reason why I'm using x here is basically not because it's an x and y. I'm just using x as a variable in maths, not as our variable we have defined in the program itself. So first we have x and y arrays which are the same indexes respect to one another, right? So the index in x, if you take the 0 1, the first index is always going to be equal to the value of the y array also. Because why? Because we are defining both the values at the same time in the first for loop, right? So if I ask the value for, okay, give me the third index of x array, so it's 0 1 2 3, and if I take this index and call it into y, x and y, we're going to take x and y, right? We're going to get a point within the canvas, and the reason it should be same, the index should be same, is obviously if I take 1 and if the y array is shuffled, so this one is not going to be equal to this one, right? Because we are shuffling the array. So if I take these two x and y values, we wouldn't get the same point as we got in the properly arranged x and y arrays, right? So imagine if I sorted both the arrays, right? So imagine this is from smallest to biggest, right? So the one index of x and one index of y is not going to be the point we already defined in the length function. So that's why we have a properly distributed array, and that's also the reason why we have copied our distance array as well, because the distance array, the way it's arranged is equal to how we arranged or defined our length variables, right? Because we are doing it within the same for loop. So the distance of index 1 x and y is always going to be the same distance within the distance array. So now if I have to sort the distance array itself, then obviously the distance is going to change, right? So if I have 10, 15, 1, 6 and 5, without sorting the original array, the distance array which we have defined within our for loop, the index of these three arrays are going to be equal. It's going to be the same no matter what. So if I ask, give me the index 1 of x and y array, they both are going to have the same index, unaltered index. That is also same for the situation in our distance array, because we have pushed them during the same time in the same instance of a loop. So these two's distance is equal to this index, so one of these two is going to be always 1. Now imagine if I shuffle this from ascending order, right? So it's going to be 1 is going to be here and 5 is going to be here. So now if I ask, give me the distance of x and y, which is index 1 within the distance array, it's not going to give me 15, it's going to give me 5, which is the wrong value. And this is one of the mistakes I've made earlier on, which gave me a big headache. So trust me, get your indexes correct and always make a copy before you sort something. So enough of the explanation. As you can see in the code, I think code is going to explain a little bit better. So why we are giving a different variable or why we are copying the distance array is because we don't have to change the order it came from the for loop. And the reason, because we need the index. And the reason why we need index is because we want to reduce the amount of code we are writing. By using index, we can just use one value to take the values from 2 or 3, even 4 arrays, right? If we have to do it in a traditional way, we have to ask the values 4 different times, so which is going to take more variables and more lines of code, which is going to be more frustrating. We have copied the array, distance array, and we have sorted it from A to B, which means smallest to biggest. Then what we're doing is getting the index of distances in the distance array using sorted array values. So what we're doing here basically is let index, we are defining a local variable within the for loop, is equal to sort distance I. So now what we are doing here is we are going through each value inside our sorted distance. So we have a distance array. Originally we have random numbers 10, 1, 3, 5. Then we have sorted it. Now it's 1, 3, 5 and 10. But this arrangement is not equal, the sorted arrays arrangement is not equal to the arrangement of our x and y coordinates, right? But the original distance is equal to the indexes of the x and y. So what we're going to do is we need the smallest value, we need the smallest closest x and y point, but we cannot do this here because we don't know which is the smallest point within the distance array. So we have sorted the distance array to get the smallest distance, which is our first distance, right? But we cannot say get this index, which is 0, and take it from, use this index in the x and y. We cannot ask our program to use our sorted array's first index 0 and get that respective point x and y. It's not going to be equal. So what we're going to do is we're going to ask our program to get the index of the first point within the original array. So 1 is going to be the index of 0, 1, right? And 3 is going to be 0, 1, 2. And now if we say this index, we say x1, y1 is equal to closest to center, it makes much more sense because 1 is the smallest distance within the distance array and the index of distance array is equal to the order of indexes in the x and y array. So the sorted distance is basically we are sorting the distance and asking the index of the sorted value within the original value, and then we are using that index to get the x and y points, the x and y coordinates. And the reason why we're not using only 0 is because, as I mentioned earlier, we are arranging the points in the point cloud respective to the centermost point. I demonstrated it earlier in Paint, and that's what we are after. We are going to distribute the points, rearrange the points, sort the points in the point cloud in ascending order respective to the centermost point, and that's where we are running through the entire sorted distance. And then we're going to say index list, which is another array defined here, which is going to be our index list. And now here our x1 and y1 is going to be this orange point here, the closest point to the center. So as of now our index list, our sorted distance list, is in respect to the centermost point, or the center we have defined, or the centermost point, the center we have defined, which is 0, 0. So x array index list 0 means the first point closest to the center, which is obviously this point, the orange point. So that is going to be our x1 and y1. The next step is running through the for loop and sort the indexes based on the distance closest to the point nearest to the center, which means that we're going to sort the point cloud in terms of distances closest to this orange point. So let's see what we're doing here. I have defined x1 and y1 two times, so that's going to be a little bit confusing, but fortunately this is a local variable. So we're defining inside the loop, once again we are defining x1 and y1, and this x1 y1 and x2 y2 is going to be for the distance function. distance line function. So distance line and distance function are both the same. As I mentioned earlier, the distance function is only taking 0 as an argument for x1 and y1, whereas this time we have to take the arguments, all 4 arguments for this to work. So x1 is obviously going to be the closest point to the center, which is our orange point. Y1 again the y coordinate of the closest point to the center. X2 and y2 however is n, which means we're iterating through each value within the x and y array and checking which is the closest point, and sorting them in terms of distance to the orange point. So we're basically saying network distance. So I have defined another variable here, a new variable which is called network distance, and it comes after here. It's coming in our array initialization, network distance here. And so we're saying network distance dot push distance line x1 y1 x2 y2. So we're gonna take a quick look at distance function as well, distance line function. It is pretty much the same I've explained earlier. It's going to return the math square root of x2 minus x1 the whole square, y2 minus y1 the whole square. Here I've put x1 and y1, but I haven't had any issues. So x1 is going to be the defined point you want to find the distance to, right, which is going to be our orange point. So x1 is going to be the x coordinate of the orange point, y1 is going to be the y coordinate of the orange point, x2 is going to be the x coordinates in the x array, y is going to be the y coordinates in the y array. So now we are pushing the distances, and then we have the sorted node network distances, which is basically the same as we've done before, only this time I've used the slice method instead of actually copying it as I done earlier. So we are doing basically the same thing. Sorted network distance is going to hold the values of distances respective to the orange point, which means all the points distance to the orange point and sorted, right? Now we are using a for loop. For let f is equal to sorted network distance, we are going through the sorted network distance, and we're setting a local variable value into sorted network distance values. So it's going to go from smallest to highest, and we are getting the index. So this is another recurring pattern you have seen. We have done this earlier on. We're gonna get the index, only this time we have renamed it to value, item inside our sorted distance, and we're getting that item's index within the unaltered or unsorted distance array. So we are doing the same here. Let value is equal to the item inside sorted network. So we're getting the index of the sorted item within the unsorted array. Why? Because the unsorted array's index is equal to the x array and y array we have generated in the first for loop. And I'm pushing the indexes into an array again. So I think I've sorted node, yeah, so we have an array here, and that's going to hold all the indexes. Why we are holding all the points in the array? Because as I mentioned in the first bit, I explained how the pattern works. We need all the points to work, right? We just don't need, like in the previous video I have shown an explosion, we just need the index of one point, and we can randomly connect that one point to every point in the point cloud. But we are doing the opposite here today. We need the index, we need the x and y values to see which is the closest value, right? So which is the closest to the orange point, this point here. Draw a line, add it to the network, and next which is the closest point among the network to this point. Okay, we have to connect it. It's kind of a neatly tied procedure. You need all the values, you need all the information as you can. So after that, what we're doing is loop to the sorted distances and get the closest distance for each point in the sorted index. Okay, so this one is pretty simple. I'll try to explain it in Paint quickly. So what we have here is node distance array, and we have copied the sorted node index, right? So the sorted node index is holding the indexes in order of smallest to highest distance. So we're making the copy of node distance as well. So node distance is a copy of that sorted node index array. And the reason I'm making too many copies is I don't want to alter any array, so I can come back and do that original index referencing. So next we are defining nodes in network. So we are shifting the first two values, and the reason for that is, as I mentioned earlier, to draw a line you need two coordinates. You need four coordinates, x and y in the first point and x and y in the second point, right? So to draw the first line, what I'm doing is shifting the first 2 points in the node distance index into this one and 2. So now here the length is going to be -2, and here is going to be +2. The reason why we need two indexes is we can use this index to reference to two x and y coordinates each, and those two x and y coordinates are going to be the coordinates for our first line. So for example, we have all these points. The first node index is always going to be 0. So to draw a line, we can't draw a line with just one point, right? We need a second point. So that second point is going to be a second index. We're going to use that index and reference it, and use that index and access the values inside x and y array. And now since the index is properly sorted out as the smallest distance to highest distance, the second index is always going to be the closest point to the center. So this is going to be a second index. So once that is done, and the reason why we are doing this before making all the complicated decisions is we need something inside the network for the third value to reference to, right? I mentioned earlier that we have a circle and we have a couple of points. I don't think so you guys can see this, right? Okay, so we have a couple of points. I'm going to draw a point cloud array just for simplicity, right? Point. It has all the values you can think of, right? It has all the values, information of the points within the point cloud. But then the network, if the network is empty, right? It has empty, no values, right? So my logic was take the first point and compare it to the closest point within the points in the network, which means take a point in a point cloud and check which it is closest to within the network. But if a network has no values inside it, what are we going to compare it against? Actually nothing. So that's why we have shifted the first two values and drawn a line. And the reason why we have shifted the first two values is because we know that they are in the proper order because we have sorted the distance accordingly. So now if we have two values, our third point has something to compare against. So our third point is going to be, oh well, we have two values already inside. So if closest point to the center is these two, so our third point comes in is like, okay, within these 2 points, which am I closest to? Oh, it's basically this guy. I'm gonna connect and I'm gonna delete myself from the original point cloud and come inside the network. So now within the network we have 3 points. So it keeps going like that. So we need two initial values for the entire process to work. That's why we are shifting values from the node distance array into the network. Obviously we are drawing a line, the first line right here. So I can actually differentiate this line by using a red color. So now we can clearly see what I'm talking about. Look, this is our first 2 points in the network, and that point is always red color, right? Because we are defining those 2 points to be the first in the network. and we need 2 initial points for the entire process to work. I'm pretty sure there are some other workarounds for this, but for me this has worked the best. As you can see, the results are amazing, so let's stick with that. So the next step is obviously the looping process, which means we have to go through we have to repeat this process for all the points in the point cloud. So if you have understood the first two processes of how we are getting the first 2 points to connect to each other, the rest of the loop is going to be very easy. So next we are running a while loop to get the distances between points in the sorted distance array. So we have a while loop, and we're gonna say as long as the node distance dot length is greater than 0, keep going. So that is basically equal to our point cloud greater than 0. As we're going through each point, we are shifting it into our network, right? Eventually our point cloud is going to be 0. This array is going to be 0 because all the points is going to be going into the network, and network size is going to be equal to the number we have defined, 30. So until this thing is 0, keep running the process, right? So we're gonna say in1 basically means the index number 1 of node distance 0, which means the closest point to the center, our orange point. Okay, so I've made a mistake, I'm sorry, but the thing is, node distance is 0 is not the orange point. It is the third point, right? Because we have already shifted the first 2 points. So now the first point in the node distance is going to be the third closest point to the center. So now this makes a lot more sense. So we're gonna run the for loop to get the distances between the third point, which means this point I'm hovering over, this point or this point, right, which is closest to. And this point is the node distance is 0 because we have shifted the first 2 values. So the third value is going to be the third closest to the center. This point is going to be our x1 and y1, x and y coordinates of this point. Then in the for loop we are defining x2 and y2, which is the nodes in network, which means the orange point and the red line connected, right? The point that's connected to the red line, this point and this point, x and y of these 2 points we are taking, and we're also taking the distance between from the third point from here to here, and the distance from here to here. So we're taking the closest distance of that and we're connecting a line to that point. So let's see how that goes. So we have node near current, basically we are pushing that. We have defined an array here and we're pushing the distance between the first point in the node, the point cloud, think of that like that, the point cloud after we have shifted the first 2 values. So the first point in the point cloud is going to be the third point, and then we're taking that x and y value and taking the distance from that value to the values within the network. That's why we have defined it as network.length, because from each iteration the network's length is going to increase. So now, as I mentioned earlier, we have the distance near current. I could have really just sorted the node near network, but to avoid again manipulation of wrong arrays, I've made a copy and put it into a new array called distance near current, which is more self-explanatory. The distances of points in the network closest to the first point in the point cloud. And the first point in the point cloud doesn't necessarily mean the first point itself, because we have already shifted, and end of each while loop iteration we are also removing the point, right? We are removing the first point. So the point next to the first point is always going to be the first point at the start of a while loop. Again, we are sorting the distances from smallest to biggest to get the closest distance. Okay, now I understand why I have copied the array, because we need to get the index of the closest value within the properly arranged indexes, like the one we have done earlier on. Pretty much the same concept, just looping over and over again. Index of near node is equal to node near current dot index of, we're getting the index of the first value, so it's going to be this value within the unsorted distance array, and that unsorted distance array's index is equal to the index of the node network itself. Okay, so once we have gotten that index, we are removing the value from the point cloud, which is going to be our node distance array, and pushing that shifted value into our network. So basically removing this point from the point cloud and adding it to the network. Now the network has 3 points, and the reason why here it's node network length -1 is because before we define this node 1 variable, we have already pushed a new value, and that value is the shifted distance, right? So since it's a new value, it's always going to be the last value. To start with, we only had 2 values in our network. Now after we have gotten the index of the closest value in the network to this point, we are pushing this point into the network and removing it from the cloud. So now we have 3 points. Now since we have 3 points, this point is always going to be the last point because we have pushed it. So we are saying node 1 is this point, node 2 is this point, the closest point to node 1. So that's what we are doing here. X line 1 is equal to X array node 1, which is this one, Y array basically this one, X line 2 is node 2, which is the closest point to this node, and that is this point. And now we are drawing it, we get one line like this. So basically we are going to loop over again. Now after that's done, it's going to go up while length is greater than greater than 0. We are still waiting for the point cloud to come to 0. So again index 1 is equal to node distance 0, which means the next closest point, which is going to be this point, right? That's what we're taking here. X and Y is going to be this point, and let node near current, and we're going to run a loop iterating through each point in the network. So these 3 points are now in the network, these 3 points, and for each point we're going to check the distance from this new point in the cloud, and to each point we're going to scan, right? We're going to scan through all the points in the network, and then we're going to say x2, yeah, we're going to take the distance and push it into node near current array, and let distance near current is copied from the original distance array and sorted from A to B. Next we are saying index of near node is equal to the index of the closest point, which is the first point in the sorted distance array, which is going to be this point. Why connecting to this point? Because these are the only points within the network we have added. So now we're going to come again, we're going to say nodes in network dot push. Now this point I'm hovering over the mouse is added to the network. So now the network's length is 4. We have 1 2 3 4 points. So once that's added, this point is obviously going to be the last point added. So it's going to be networks nodes in network dot length -1. So this is the last point, latest point added. Draw a line from this point, which we are defining here, X array node 1, and the second point is the index of near node, which is this point, and we're going to draw a line. So this line is drawn. So that's pretty much it. I hope you guys understood. If you guys do have any doubts, please let me know. I'm going to increase the number to about 400, so you can see how beautiful it is. It's working perfectly. Yeah, so you can see the branching pattern is quite really perfect, I should say. I could even go higher to like 500, and we'll have this complex structure of organic patterns, right? It's quite marvelous. We can achieve this with programming. So that is pretty much it for today's video. If you guys enjoy this video, make sure to leave a like, and if you guys have any questions about this pattern, or this video, feel free to contact me on Instagram, or you can just leave a comment. I'll try to reply to the best of my abilities. And I feel today's video was much more productive than the last one, but I think during the last bit of today's video I feel there's some improvements that can be done. So I feel there's going to be a lot of questions coming in, which I'm open for, and I'll try to help you to the best of my abilities. So thank you for watching, and I'll see you in the next video. Bye bye.